The devil's in the details. This week, the guys get crafty with the steering column and brake assembly.
I come bearing gifts.
Banks built, protected by AMSOIL, with support from Roadster Shop and Nitto.
We got this box in today and we got to open it quick because steering is going to be really important for building essentially everything in the engine bay around.
We have almost no room. This engine compartment is really tight in here with this L5P, and with the Roadster Shop chassis it's got a front-mounted rack. So we've got a steering shaft coming out of that rack that we've got to get around.
It's tough to see, but yeah, our steering rack essentially shoots out into the motor mount, and then right behind that we've got the exhaust manifold, and then the cab's not far behind.
We reached out to our friends at Flaming River. We've got these boxes. We've got a steering column. We've got, I think, a 36-inch shaft. We've got 3 U-joints, and we've got an intermediate support because the center shaft is going to need to be supported. Otherwise, it's got too many degrees of freedom, and it'll be floppy.
So this used to be a manual transmission, so this is what's left of the clutch. We've got the gas pedal out. That was a floor mount. This is the what's left of the clutch, and then the brake pedal. There it goes. Everything must go. Oh man, there's something so satisfying about just cutting whatever wires you want. All right, that'll give us enough room for steering. It's dusty in here.
I bequeath you, sir, with the column.
Oh, I should have washed my hands first. This is too shiny.
If you were a doctor, this would be like an 80-pound cast.
That's why I'm here, not in the doctor's office. Put it right there.
All right, so we're trying to figure out exactly where we want our steering wheel to mount relative to the dash. So we've got our sweet mock-up seat in here. So we're gonna zip tie it in place for the moment, and we can slide it around a little bit and get comfortable with it. This is the deluxe zip tie method of steering column mounting.
Because we forgot a part. Thank God I have more. I don't know who's stocking our zip tie cabinet, but...
All right, so this U-joint is now locked onto the rack and pinion via the pinch bolt.
Okay, let me grab a fresh zip tie and pop that back in place. My mechanism is not ingenious, that's my problem.
We can mock up the 2 shafts without that support in place, and then figure out where the support's gonna go.
Try to get it as centered up as possible on this guy without protruding into any other space.
We got shaft, we got U-joint. Let's get this piece in and see where this lands.
We got our crash test dummy in there now too.
All right, we got the first piece in, we got a U-joint, we got a double D shaft. Now let's measure and cut for the next piece.
You're gonna wanna have your arms a little outstretched. You're not gonna wanna do the granny driver where you're compressed, you know,
I know, but
elbows.
So your butt is like really far back right now.
Yeah.
So when your butt slides forward, which gives you, I mean, look at your legs right now, right?
Yeah, but I'm still compressed right here.
How do you normally drive?
I'm leaned back like Snoop.
Yeah?
Aren't we all? Don't we all drive like this with your arm kind of?
I can try to hold that U-joint.
Let's call that 8 inches. Plus 7/8.
Plus
7/8.
Okay. That'll do it.
All right, you got the piece.
And then it's just fine tuning from there.
How's our left and right angle?
That looks pretty damn good. We are just barely before 35. We're probably at like 32, 33 degrees. We are good. We're like right at 35. Plus this is loose in space, so this will come up a hair. Yeah, if we get a good angle, since it's, you know, it's threaded, we can have a little bit of adjustment there. So
yeah, we got our angles pretty good. We got the column pretty much where we want it. Steering position feels good in the hand. Arms are at a good length.
And we'll land under 35 degrees for every U-joint.
Yep.
So
yep.
No binding.
Yeah, I think we can, even though we don't have any time, I think we can stop for today, and we'll come back tomorrow and work on headers, work on support bracket position, and keep cranking away.
More off the list.
All right, so we mocked all our steering into the car the other day, and we got everything lined up roughly where we wanted it. So I came back to my desk and I put everything in CAD so that we could design a bracket to hold the bearing support. Since we have 1, 2, 3 U-joints, we have too many degrees of freedom. We want to be able to rotate, but we don't want to be able to translate. This spherical rod end will keep that translation from happening, but we have to get it into the chassis somehow and hold it there. So came back, designed a bracket that Erik is going to cut on the plasma cutter, bend up, and weld into the chassis.
So we got the bracket from Matt. We exported it into a DXF, so essentially it's a 2D piece, and the way I was able to program it is that I could take it in, and as you see here, so in green, those are our bend lines. So what I'm able to do with the Torchmate table is go in with this pneumatic engraver and actually engrave that bend line. So that way I engrave it, cut out the internal features, then the external features. And with that, instead of going in with either a Sharpie or a scribe and trying to get a real accurate bend line, they're already taken care of. So I can go from this, a little bit of deburring, right to the finger brake and get this thing bent up accurately. Yeah, you're good. I want to make sure that my bend lines are on the back side here, so that's flipped. Okay, that's good. Got our bend lines, corner relief, real minimal dross. Cleanup will be quick. We'll be ready to tack this thing in real soon. Okay, so for you, those of you who don't know, this is a finger brake, also called a box brake sometimes. This one has all these little fingers and they're set distances, so you can go in with different parts depending on your widths and bend up these intricate boxes with the fingers. So all that's going on here is you've got your fixed plane, split line, and then this whole piece here with these yellow counterweights is what actually bends up the material. And it's adjustable, made for thinner stuff though, adjustable for clamping pressure, so you can go really thin, say, you know, 030 nothing aluminum up to 095 mild steel, or if you're like me, you use 109 mild steel and push it a little bit beyond its limits. So a big thing here is bend radius. So when I go and make a part like this, if you have, you know, crucial surfaces against each other, you have to count for a bend radius. And a bend radius is adjustable on this machine. I like, the rule of thumb is 1 times your material thickness up to 1.5 times your material thickness. I like to go just 1 time your material thickness because it's easy to set. So if you go ahead and clamp down on both sides, you can set your bend radius. It's essentially going to be the gap between the front of the finger and your split seam. So what I'll do is I'll take the piece, and I already have this preset, but essentially it perfectly fills that gap between the front of the finger and that split line, so that I know when I go ahead and bend this up, it's going to have the bend radius that's equal to the material thickness, which we accounted for when we designed it. And these can catch you because they never actually truly hit 0 or truly hit 90. They go right past it. So as we come up on 0, you're actually never going to see 0. It's going to go right past it and start counting up as you go beyond your 90. And I'm going to go right to 90. I might have some material spring back, but I'm going to go right to it and see how close I get. Looks pretty damn close based off an eyeball, but I'll double check that. Matt, what's my bend angle? I think he's in his office. I came in so hot on that. Overshot, but we'll make it work. So get on there and then whoop. All right, we're ready. All right, so now I got to mark out where I'm grinding frame side, make sure there's no mill scale, and then weld the jam nut to the back side of this guy, and then it'll be ready to tack in place. It's the most screen time one bracket has ever seen. What I need to do here is I'll clean off a spot, and I want to actually pull the bearing off, put it through and tack it with it in position so I know that this thing is concentric to the hole. because it's really easy to get it slightly off, and then I go to put in the support bearing or the heim, and it does not go through, and then it becomes that much more of a pain to weld to clean up the through hole, because I got to get the through hole but not the threads. So good practice to put it through when tacking and welding, or tacking at least I should say, not welding. Don't want to destroy the threads. But first, we'll do a little science project. So this is muriatic acid. I want to say it's slightly diluted hydrochloric acid. Same stuff you put in your pool, I believe. And what this is going to do is strip our zinc-coated jam nut of its zinc coating. So, turns out it's not zinc coated, it's just stainless. And I would have known that had I used a magnet to verify. Got it. So, botched science project there. It turns out it's not zinc coated, it's just stainless. I should have known that. So I got an actual zinc coated bolt. So I'll show you what I anticipated was gonna happen. So the acid just strips the coating. Let me get this out of here so you can see. Strips that coating right off. So we'll give it a minute. Wait, no, we can't get copyrighted. Welding zinc coated stuff is not only an absolute pain in the ass, but unhealthy for your lungs. So I learned this little trick from one of my old instructors. So now it's done bubbling, and so that there is a raw steel nut compared to a zinc coated nut. Very carefully, go under. All right, we are tacked in place. That will stay for mock-up. Okay, so we've got the support bearing hidden under the motor mount tacked in. Then we've got zip ties holding it in at the stock strap clamp. There will ultimately be a firewall support to keep it from sliding out, but I've just got it resting on this towel just to go ahead and show you guys that it turns. So once this is locked in, it'll be fully supported and will not shake around like that you see when I'm turning it right now. That's only because there's no firewall support, but we'll have a through bearing at the firewall for that. Roll the window up, we're losing the hot box, man. It's a heavy duty degreaser. Citrus based, smells great. All right, let that soak for a minute.
Okay, so we cleaned some of the junk out of inside of the cab. We've got a bunch of the insulation gone now. The dash instrument cluster is out of the way. 50,000, no way that rolled over. So now what we can do is we can build a bracket that's going to pick up off of some of the underdash mounting points behind the steering column, the front steering column mount, and we can pick up on some factory points and make a bracket that holds the brakes and holds the lower steering column and ties into where our firewall will be. Okay,
so it's
so here, they're in line here.
Brake pedal here.
Okay.
Yeah, but they're over. Yeah, it's right about in line.
Maybe we can make use of this. We can tie the bracket into these.
Out of all the four that are stripped, it's only that one.
This is the one I wanted.
Or out of all the four that are there,
yeah.
That's the only one that's stripped.
All right. Nuts. I guess I'll take some measurements and try to CAD this up, and we can plasma a bracket.
Okay. And then what time is it? Jay should be back with that grill.
Yeah, it's almost noon.
All right. I'm gonna finish out this floorboard first.
They come bearing gifts. There's a grill from a 1960 Chevy. The dude collects old Chevy parts and sells them out of his garage.
That thing is clean, man.
Yeah, straight as an arrow. Well, I mean, a little bit of dip here.
Yeah.
But that's nothing we can't massage out. He goes, are you gonna paint it? I go, I don't know. Might end up being copper based on what we're seeing in the comments.
Yeah. All right. Let's get this thing on the truck.
Yeah, let's fit it up.
All right. Here we go. 60 Chevy grill in 66 Chevy truck.
So we got stuff to cut.
Yep, we're gonna have to, so this will be fine. We've got plenty of space back here.
Okay, so I've got some hand measurements, all you scan haters out there. So this is gonna locate in CAD this bracket so Matt can go and design a piece to tie it all into the firewall, the brakes, the steering, all that good stuff. So we've got the slotted internal spread here, just over 4 3/4, hold the hole just under 3 inches. Column center line, board flange, about 1.5 inches.
Right.
I've got the firewall distance from slot center line, about 10 inches. Firewall planes, about 7 3/4. That's about it. So to the frame, I hung a plung bob from the inside face of inside of the frame rail. Inside plane will basically be where exactly.
That's awesome.
So that'll get us really close by hand.
Okay.
Without a scanner.
Well, I'll take those dimensions then. I'll go back to the computer. I'll add it to all the stuff I've already CAD'd up. We'll get some metal on the plasma and get burning.
Let's do it.
Okay. Eric got me some dimensions out of the truck itself so I can draw the bracket that's under the dash, so I can draw a bracket to bolt to that bracket. And we can hook up the brakes and we can hook up the bottom of the steering column so that all of that is supported. So I'm going to take this model and I'm going to take this model and I'm going to make an assembly of the two and put it into this model. And that will locate everything and allow us to make that final bracket, and then we'll have our steering and brake positions locked down in the vehicle.
While Matt works on the brake and steering mounting assembly, Erik cuts into the cab to make room for the drive shaft.
That was the easy part. I've got the floor cut out. I am ready to start cutting up into the cab, but I don't want to cut off more than I need to. And we actually don't have this rear end placed in CAD, but we have the entire chassis. So what I'm going to do here is grab a reference measurement. So I've got this thing fully tucked up in, no air in the bags, jack stands are under the rear shock mounts, so this thing isn't getting any higher. And I am going to get a plane here with some string so I can take the centerline measurement of this third member connection on the diff, and that'll be our centerline connection all the way to the trans, which is in the CAD. And then we'll have the OD of the drive shaft, and we can use that as a reference measurement so I can go and know just how much to cut out of that cab. So the curious part about this one is I got to grab a nice reference measurement, but this the inner controller mounting, this entire thing is sloped relative to, say, like a flat plane of this guy, so I got to figure out the best spot as my reference plane to get the centerline measurement here. And so now I have my fixed plane. I know the step off of these frame rails, and I can grab a straight down centerline measurement and use that to go and extrapolate. We're a 1/16 under 18 1/4. So 18 and, why did I just say it like that?
The bus leaves Chicago at 3 p.m.
18 3/16. All right. It's been a long day. 3 inches from 18 3/16 off that cross member, 3 inches down. And then it's also a 3:15.
All right.
Just so you know.
Yeah. Time for a beer is what it is.
Yeah.
All right, I'm gonna go put that in CAD.
Okay.
So we measured for some drive shaft stuff. Here we are in the CAD.
So what Matt's doing now is he's making the plane where the back of the cab lands relative to the chassis. And I see you've already got your center line to center line.
Yeah, so this is the center of the rear end U-joint when it's fully compressed.
Yep.
So from this surface down 3 inches, and from the back of this cross member to this surface is 18 1/4 minus 1/16.
Yeah.
Yeah.
Got it. Same page.
And then I went to the center of the U-joint on the front, and that's what this lovely line is representing, the center line of our drive shaft.
And is that a cutting jig I see?
So now we have a cutting jig. The drive shaft we're going to use is probably going to be 3.2
OD
inches in outside diameter. So I went a little bit bigger. I think this is 4. Gotta do my metrics here.
We need American conversion right there, American units, freedom units.
3.75. So like 1/2 inch of clearance at full compression.
I think that's a fair air gap.
And there's the jig
ready to
that you're going to cut on the P cutter.
Yep.
So it locks you in on each side, it locks you in vertically, and then you push it up against the cab, mark the cab, cut the cab.
Beautiful.
We're done.
Beautiful. All right, you want to give me corner reliefs on those inside corners and export that as a DXF?
Yes, sir.
All right.
All right, let's do it.
I'll get the plasma fired up.
Okay.
Jig, job code file, 109, 40 amps. There you go. That's all there is to it. All right, got it all deburred here. It looks like we are a little bit off. I'm just eyeballing the center line right now. It looks like we might be shifted over a hair. So what I need to do is mark out the center line of this rib and mark out the center line of my jig. And then I can go Sharpie that on, and that'll be my cutting line for the back of the cab. And then connect this opening to the opening of the floor currently. And that will be our rough cut for the driveshaft tunnel. There's that cross section of the, looks like a spot welded gusset doubler rib, whatever we want to call it. Bye-bye.
All right, guys, Sunday morning now. Eric and I stayed late last night, and the thing we finished up last night was this steering / brake pedal master cylinder mount bracket. Mounted it with some factory holes, and it turned out pretty good. It gave us a really good idea of where everything is going to land in the truck, but it's not quite right.
All right, out with the old, in with the new.
Oh, there we go. All right, there's the first one out. Version 1 we just pulled out. Extra stiffener added to it because it was tweaking a little bit. So version 2, ready to go in.
Okay, now they're parallel and the gap is maybe like 3/8. So with the main portion of the bracket, we pretty much hit the mark. So what Matt's looking at now is the ears that come out and grab where the strap flap would go for the steering. We came up a little bit short on that gap, so what Matt's looking at now is that exact gap between the interfaces, so we can go and rev those little pieces that I didn't tack on purposely because of this. We knew it was probably going to be a bit off. So he's grabbing that distance. We're going to make a small change, cut those two pieces out again, and then do one final test fit, and then we can tack them on, and then final welding.
It's a good angle. That's a nice shot you've got. All right, well, second master cylinder going on. We got our bracket all welded up and in place. Looking really good there. Fits really nicely. And look at the placement of those master cylinders. What do you think, Eric?
It's perfect.
Yeah, once we get that firewall in and we get
that'll be the final
steering
piece.
column mounted,
It's tough to see, but
that thing's really going to stiffen up even more.
Yeah, I don't know if you can pick that up.
And how about that brake pedal? How's that brake pedal look in there?
Probably about as close as we can get to the column without running into issues, which is exactly what we need. And we can tuck up, since we're throttle by wire, we can just run that right up on the opposite side and have a nice one-footed operation still.
I like it. I like it. It's looking good. Everything's fitting nice. It's everything's coming together. Almost like we planned it that way. Well, should we get the
steering back in?
The steering column in, yeah.
Let's do it. Hold on, I gotta get my zip ties for my strap clamp.
Brakes and steering are in now. We're waiting for a few more pieces that are going to come, let us finally clamp it into position, but pretty much we can check that one off the list.
Yeah, the only thing that's really might need adjustment is tiny length variations to the actual shafts once we have the support bearing.
But I'm comfortable right now if we tighten some set screws down and we clamp the column before it hits the road, that we're going to be good to go.
Yeah.
And we can deal with that stuff after the truck comes back from sheet metal.
Yep.
So next thing we're going to move on to is we got to get hood hinges on here. So you guys have seen the 6-bar linkage that I designed, and I've refined it a little bit, and now I'm starting to make some bracketry to mount up to our core support here. So these are going to mount to some existing holes on here, and then that 6-bar linkage will sit in this area right here and pull that hood right over the top.
Next week, the guys continue burning the midnight oil, finalizing the custom-made hood brackets, air intake, and intercooler, all to make the deadline for sheet metal work.